So we already know the rectangular coordinate system. Now let's see how to use distance formula. A lot of time we are wondering, what's the distance between two arbitrary points, right? How far away from two locations, for example, in the real-world application. So how can we find that out? We can use some of the geometry knowledge, we learned from middle school. For example, there are 2 points, one point with coordinates 1, 3, and the other point with coordinates 5, 6. And then we can draw a horizontal line from the point 1, 3, and draw a vertical line from the point 5, 6, and then we form a right triangle here. Okay. So now the question is converted to the geometry problem. In this right triangle, we try to find the hypotenuse, right? We want to find how long, the length of the hypotenuse. So in this right triangle, what is the two legs, the sides? Because this is the horizontal line, so this line should have the same y coordinates at the points 1, 3. And this line is the vertical line, so this point should have the same x coordinates of the points 5, 6. That's why we can easily figure out this point coordinates should be 5, 3. All right, so in this vertical line segment, because x coordinates is the same, right? Both 5. And then from 3 to 6 is obviously that's going up 3 units. And similarly, for the horizontal line segment, since y coordinates remain the same, right? So the distance between the two x coordinates should be the distance of this line segment. So the leg is 4. And in the right triangle, we know the length of the two legs. We try to find the length of the hypotenuse based on the Pythagorean theorem. We can do d squared equals 3 squared plus 4 squared, right? Which is equals 9 plus 16, that's 25. So d squared, the distance between these 2 points, we use d to represent. D squared should equals 25. Therefore, we know d equals principal roots of 25, which is 5. Okay, so we use geometry method to solve the hypotenuse of a right triangle. So actually, this is a theorem. Okay, we based on this derive a distance formula, and then this is a theorem. So that means it's already been proved. You can use it directly. Okay. So the distance between any two arbitrary points, we denote the two arbitrary points as P1, P2, where P1 has coordinates x1, y1, P2 has coordinates x2, y2. And then we can describe the distance between P1, P2 using this formula, which is square root of the distance of the 2 points x coordinates square plus the difference between the 2 y coordinates square. Okay, square root of the difference between 2 x coordinates and then square difference plus the difference between the 2 y coordinates square. Okay, that's how to find the distance between 2 points. And the proof actually is the same as I show you. The only thing different is earlier we used the concrete number, now we use general notation. Okay, but it's still using Pythagorean theorem. Okay, which is c squared equals a squared plus b squared. Okay, we still use that. And then if it's a horizontal line segment or vertical line segment, and then the distance formula simplifies, okay, because for the horizontal line segment, the two y coordinates equals 0. So no difference between the two y coordinates. That's why it's only the difference between the two x coordinate square, right? Square and the square root. That's why after simplify, that is just absolute value of the difference of 2 points x coordinates. And similar for the vertical line segment, the distance just the absolute value of the 2 points y coordinates difference. Sorry, y1. Okay, the absolute value of the difference between 2 points y coordinates. So now let's try some example how to use distance formula. Find the distance between these 2 points. So now let's make some notation, okay, in order to plug in the formula. If the point -4, 5, if we consider as P1, so x coordinates that's x1, y coordinates that's y1. Okay, let's just make that notation. And then the second point, if we denote as P2, and then x coordinates, y coordinates accordingly is x2, y2. So now distance formula, okay, distance between the 2 points is the difference between two x coordinates. So 3 minus -4, right? And then square this difference. Plus 2 y coordinates, find the difference. 2 minus 5, and then square it. And then simplify. Here, be careful, the case minus negative, okay? Minus negative, oh, that's 3 minus -4, sorry. Right, 3, this is 3 minus -4, not -3, my bad. So 3 minus -4, that's become a 3 plus 4, so that's 7 square. And then 2 minus 5, that's -3 square, right? Further simplify, 7 square, that's 49. -3 square, that's become a positive 9, right? So we got square root of 58. You can just keep the answer like that, okay? If you want to further simplify, you can use the calculator to find a decimal. That's 7.62 if we keep 2 decimal places. So that's how we use distance formula to find the distance between these 2 points. So where we can use the distance formulas for, we can use it to solve some geometry problem. Okay, let's look at this example. Consider 3 points A, B, C is given the coordinates. So first, ask you to plot each point and form triangle ABC. Okay, all right. So now let's plot it first. Set up rectangular coordinate system, right? X-axis and then Y-axis. And then put a scale. So 0, 1, 2, 3, 4. -1, -2, -3. And then the y coordinates do the same. 1, 2, 3, -1, -2, -3. All right, so now let's plot the point A, -2, 1. So you can start from the origin, go left 2 units, go up 1, right? So this is a point, -2, 1. This is a point A. Point B, 2, 3. You pan back to the origin again, right 2, up 3. So this is the point B with coordinates 2, 3. Point C, 3, 1. Start from origin, right 3, up 1. So this is point C with coordinates 3, 1. And then we use straight line, connect the point AB, connect the point BC, connect the point AC. Okay, that's the triangle we formed. And then part B of the question, find the length of each side of the triangle. Okay, so we have three sides, right? AB, AC, BC. So let's find the length of each side. So the distance between the 2 points A and B should equals what? Square root of AB, the two x coordinates, find the difference and then square, right? So that's 2 minus -2, and then square that difference, right? And then plus the two y coordinates, 1 and 3. So 3 minus 1, and then square the difference. So if you simplify, 2 minus -2, again, minus negative become a positive. So that's positive 4 square plus 3 minus 1, that's 2 square, right? So that's given us 16 plus 2, that's square root of 20. We can simplify as square root of 20, we can break as 4 times 5, right? 4, that's a perfect square factor. So we can get a 2 out of square root. So we simplify as 2 square root of 5. And then find the distance between the points AC. Okay, AC, we notice we have the same y coordinates. So the distance between points A and the point C, according to the theorem, it should be the absolute value, right, of the two x coordinates, 3 minus -2. 3 minus -2, that's positive 5. Absolute value positive 5 equals still positive 5. Of course, you can plug in the distance formula, you should get exactly the same answer. Okay, now let's find the distance between the point B and the C. That's square root, okay, BC, the two x coordinates, find the difference, 3 minus 2, and then square that difference, plus the two y coordinates, find the difference, right, B and C. That's 3 and 1, so that's 1 minus 3, and then square. So that's square root of 1 square plus -2 square, right, which is square root of 1 plus 4, that's square root of 5. Okay, so the distance between AB equals 2 square root of 5. Distance between points A and C equals 5. Distance between the points B and C equals square root of 5. Now, part C of the question asks you to show the triangle is a right triangle. So if it's a right triangle, it must satisfy Pythagorean theorem, which is a squared plus b squared equals c squared. Okay, let's see, well, that is a true statement. So distance of AB squared, that's equals what? We know that's square root of 20, right? We got earlier square root of 20 and then simplify. So squaring that, that's equals 20. And the distance between B and C, and then find the distance square, that's square root of 5 square, which is equals 5. And the distance between A and C square, that's equals what? 5 square, which is 25. So we can see clearly 20 plus 5 equals 25, right? That's exactly satisfying Pythagorean theorem. So this triangle ABC, it is a right triangle. Okay, we can add the square root. So this is the distance square. So a distance of the points AB plus distance of the point BC square should equal distance of AC square. Okay, so satisfy. Let me write it. Actually, the next slide, it shows, okay, this is the calculation of part B of the question. And then part C, you can see distance of AB squared plus distance BC squared equals distance of AC squared. So the number 4 question, part 4, asks us find the area of the triangle. Area of the triangle, let me do it here. Area of this triangle ABC should equals, based on the formula, is 1/2 of base times height, right? Since this is the right triangle, this is the 90-degree angle, right? If BC is the base, and then AB can consider as a height, or vice versa. So basically just distance of AB times distance of BC, right? And then the product multiplied by 1/2. So that's 1/2 times distance of AB. We got here already, that's 2 square root of 5. Distance between BC, that's square root of 5. So these three numbers multiply. 1/2 times 2 cancel out. Square root of 5 times square root of 5, that's square root of 25, simplified as 5. Okay, so all those calculations, you can find it from the following slides.